Trigonometric identities. Trigonometric identities are equalities that involve trigonometric functions and are true for every value of the occurring variables where both sides of the equality are defined. Sin cos hexagon. Use various ways to remember various trigonometric relationships. So this is the example. Sin theta over 1 plus cosine theta plus 1 plus cosine theta over sin theta is equals to sin squared theta plus the quantity of 1 plus cosine theta over the quantity of 1 plus cosine theta, the quantity of sin theta, is equals to sin theta sin squared theta plus 1 plus 1 plus 1 is 2 cosine theta plus cosine squared theta over 1 plus cosine theta sin theta is equals to the quantity of sin squared theta plus cosine squared theta. So si plus 1, so nala si 1 plus 2 plus 1 plus 2 cosine theta over 1 plus the quantity of 1 plus cosine theta, the quantity of sin theta. Next is equals to sin squared theta plus cosine squared theta plus 1 is 2 plus 2 cosine theta over the quantity of 1 plus cosine theta, the quantity of sin theta, is equals to 2 over 2 the quantity of 1 plus cosine theta over the quantity of 1 plus cosine theta, the quantity of sin theta, is equals to 2 times 1 is 2 and so gi-cancel kay they are the same in, so gi-cancel nako sila kay pareho sila. Then ang nabilin is si 2 og si the sin theta is equals to 2 cosecant theta. So this is the final answer of this is the final answer, 2 cosecant theta. Reciprocal identities are the reciprocals of the three standard trigonometry functions, namely sine, cosine, and tangent. In trigonometry, reciprocal identities are sometimes called inverse identities. Reciprocal identities are inverse sine, cosine, and tangent function written as arc prefixes such as arcsine, arccosine, and arctan. For instance, function like sin caret circumflex -1 the quantity of x and cos caret circumflex -1 the quantity of x are inverse identities. Either notation is correct and acceptable. Reciprocal identities. So this is the formula of reciprocal identities. Cosecant theta is equals to 1 over sin theta. Secant theta is equals to 1 over cosine theta. Cotangent theta is equals to 1 over tangent theta. Reciprocal identities evaluating secant and cosecant. Cosecant. So example number 1 in reciprocal identities. First is secant, the quantity of pi over 3 is equals to 1. Cosecant theta, the quantity of pi over 3 is equals to 1 kay sa ang answer man diri sa secant is 1, so equals to 1 over 1 over 2. So 1 divided by 1, 1 divided by 2 is equals, the final answer is 2. Second, cosecant, the quantity of negative 225 degree is equals to 1. Sin, the quantity of negative 225 is equals to 1 over square root 2 over 2 is equals 2 over square root 2 is equals to, so 1 over square root of 2 and over 2 is equals to 2 over square root of 2. So the final answer is positive square root 2, because and square root of 2 and square root over 2 is equals to 2 square root 2 over 2. Quotient identities refer to trigo identities that are divided by each other. There are two quotient identities that are crucial for solving problems dealing with trigs, those being for tangent and cotangent. Cotangent, if you're unfamiliar with it, is the inverse of reciprocal identity of tangent. This identity will be more clear in the next section. So this is the formula of quotient identities. Tan theta is equals to sin theta over cosine theta. Cotangent theta is equals to cosine theta over sin theta. First example, sin 4 over 5 and cosine theta is equals to 3 over 5. So tan theta is equals sin theta is equals 4 over 5 over 3 over 5 is equals to 4 over 5 is 4 over 5 divided by 3 over 5 is equals to 4 over 5 times 5 over 3 is equals to, so 5 so cancel si 5 o si 5, ang nabilin is si 4 and 3. So this is the final answer in tangent theta. Cotangent theta is equals to 1 over tangent theta is equals to 1 over 4 or 3 is equals to, so cancel na nako si 1, ang cancel si 1, ang nabilin is si 4 over 3. So this is the final answer, 4 over 3. Pythagorean identities. The Pythagorean identities all involve the number 1, and its Pythagorean aspect can be clearly seen when proving the theorems or an unit circle. Example, sin to the second power plus cosine to the second power theta is equals 1. Sin the quantity of theta is equals 4 over 5. So, ang ipangita is si cosecant theta. So, mao na atong para makuha si cosine theta. Sin squared plus cosine squared theta is equals 1. So, ang given is si 4 over 5. So, the quantity of 4 over 5 squared plus cosine squared theta is equals 1. So, 4 times 2. So, si 4 times 2 is 16. 5 times si 5 og si 2 is 25 plus cosine squared theta is equals to 16 because is equals to 25 over 25. This is the final answer. That's all.